For which of the following functions is the chain rule an appropriate method to find the derivative with respect to x? Remember, when we use the chain rule, we have to have a composition of functions, so we kind of have an outside function and an inside function. Let's see which one of these functions has that pattern. All right, so for this first one, let's go ahead and break this up into smaller functions. I'm going to say f of x. Let's go ahead and define that as the sine function here, right? So just taking sine of something. So sine of x is going to be our first function. And so one of our functions is a sine function or a trig function here of sine of x. I think our other function, I'm going to call g of x, is going to be 3x squared. It's going to be this quadratic function. So this right here would be our outer function, and this right here would be our inner function. So because this 3x squared or this g of x function is being input into this sine of x function, we can go ahead and write this as a composition function, and we are basically saying this is going to be f of g of x. It makes sense to go ahead and use the chain rule to take the derivative of this first function. All right, now what about the second function? Let's go ahead and see what functions we have here. For the first one, I'll call f of x. I think f of x is going to be this exponential function of e to the x power. Now what about a second function? I think I'm going to go ahead and define the second function as g of x, and that's going to be this other trig function that we have here, which is going to be tangent of x. And so you can see here that we are actually multiplying these two functions together. So writing this in function notation, it would really look something like this, where you have this f of x function multiplied by this g of x function. It's not a composition, it's rather a product. So you wouldn't use the chain rule to go ahead and find the derivative of this particular function. Instead, you would use the product rule, where you would take this function and multiply by the derivative of the first function, and then add that to the first function multiplied by the derivative of the second function. Now what about this third option? Well, for here, it looks like we kind of have this rational function where we have 1 over something. So let's go ahead and define our first function. Let's say f of x is going to be 1 over x. That's just a rational function, okay? Now if you go ahead and look at the denominator of this rational function, you can kind of see that we have a polynomial there. So I'm going to define that as g of x, and that's going to be this 8x to the 4th power minus 2x. Now, when you look at this original function here, you can see that this g of x function, or this 8x to the 4th power minus 2x, could be substituted in for this x value right here in the denominator. And this is another classic example of a composition function, where this g of x function is going to be inputted into where you see x in that f of x function. So this right here is another example of a composition function, and it does make sense to use the chain rule to find the derivative of these types of functions. And so I think it makes sense to go with answer choice D here, where we're saying it makes sense to use the chain rule to take the derivative of each of these two functions. And while this next part is a bit of extra credit, I'm going to go ahead and show you how to take the derivative of each of these functions, and you can see where we would use the chain rule. And so if we go ahead and take the derivative of this first function, you would first for the derivative of this first function, we would start by finding the derivative of the outside function, which is going to go ahead and be cosine of whatever's on the inside, which is going to be this 3x squared. Then go ahead and multiply that by the derivative of that second or inside function, and derivative of this 3x squared, if we go ahead and use the power rule, is going to be 6x. For this derivative, you would go ahead and use the product rule, right? Because we have two functions being multiplied together. So let's go ahead and take that second function, or g of x here, and let's go ahead and multiply it by the derivative of f of x, or f prime of x here. So we go ahead and take this tangent of x. If we go ahead and multiply by the derivative of e to the x, keep in mind that's just e to the x. Let's go ahead and then add on, let's go ahead and multiply the first function here, or e to the x power, and multiply that by the derivative of that second function. Now the derivative of tangent of x is going to be equal to secant squared of x. In one form, this would be the derivative of that second function. All right, now what about this third function here? Well, we have this rational function. Keep in mind, for these rational functions, you can go ahead and rewrite them using a negative exponent instead. So I'm going to go ahead and rewrite this as this 8x to the 4th power minus the 2x. Let's go ahead and raise this entire quantity to the negative first power. So we write it using a negative exponent instead, right? Now, if we go ahead and find the derivative of this function, you would go ahead and you would use that power rule first. So let's go ahead and move that -1 down in front. So take the derivative of the outside function. So it's going to be -1 multiplied by this 8x to the 4th power minus the 2x. And then go ahead and take away 1 from that exponent. So -1 minus 1 is going to be -2. And then we have to go ahead and multiply this by the derivative of that inside function, which is going to be this 8x to the fourth power minus 2x. So the derivative of 8x to the fourth power, if you use the power rule, is going to be 32x to the third power. And then the derivative of that minus 2x is going to be minus 2. So this right here is going to be in parentheses as well. And so this right here would be one way of writing the derivative to this particular function. Notice that while we use the product rule to find the derivative of this middle function, we use the chain rule to take the derivative of these two other functions, where we had a composite function of an outside function and an inside function.